Welcome to Study Loop.
This is chapter 37, problem number 16. We have two ships operated by Mavis and Stanley. So Mavis is passing Stanley by the speed of 0.8 c. And when that's happening, when she appears to be overhead, let's say this is Mavis's frame, this is Stanley's. Mavis is moving to 0.8 at a speed of 0.8 c. So for Mavis, x prime is 0. And t prime, the time that she measures is 5 seconds. And through Lorentz transformation in part A, we're asked to calculate what the distance would look like based on Stanley's reference frame. So for that, we're going to use our Lorentz transformation for both position and time from the example on your book 37.7, if you can take a look at that part. So x prime, the position as measured in Mavis's frame, plus u times t prime. This gives the position for Stanley. And the time would be gamma factor t prime plus u x prime over c squared. Now all we need to do is plug in the numbers into the calculation. Let's calculate what gamma factor is, because we're going to be using it over and over again. 1 minus 0.8 c squared over c squared. What we get from here is 1.6666, a lot of 6s and 7. So let's write it in terms of 1.67, okay? Let's roll it up. Now, using the first equation, x then is going to be equal to 1.667 times x prime. We said this was 0, right? So we only have u times t. U is 0.8 times c, speed of light. So let's write 3 times 10 to the power of 8 times t prime would be 5 seconds as it's measured by Mavis. Now then the distance traveled is going to be equal to 2 times 10 to the power of 9 meters for Stanley. Now let's do the same for time. 1.667 times, again, our x prime is 0, so this entire term is going to be 0. All we need to do is then multiply 1.667 by the time measured as Mavis in the Mavis's reference frame. So it's going to be 8.335 seconds. Now in part B, so the time interval, from Mavis passing Stanley overhead and turning on the light, we're asked to calculate the time as measured by Stanley. So obviously in this case, the t naught, the proper time, is the time that Mavis measures, because t naught is 5 seconds, right? Now, in order to get, let's remember the time equation. T naught equals t over gamma. And in this case, we're given t naught, we're looking for t, so gamma times t naught is going to give us the time as it's measured by Stanley, time that takes between these two events, right? Mavis passing the ship overhead and turning on the lights. Now, gamma was calculated to 1.667 times t naught was 5 seconds. As you can see, we're actually getting the same answer as part A. Same as part A. Right? It couldn't be any other way. Now, part C is asking us to calculate the distance traveled in the same manner. So what we have is then it's it's going to be v times t for our case, right? So v is 0.8 times 3 times 10 to the power of 8 meters times the time that we calculate is 8.335. So when we do this algebra, again, we're getting the same answer as we got in part A.